Hey there, and welcome to your last video from, or your last textbook video from Unit 7. This covers topic 7.6, which is reduction of air pollution, and topic 7.7, which is acid rain. So topic 7.6, how do we reduce the amount of air pollution that is emitted into the atmosphere? Guys, the biggest thing to remember is whenever you want to reduce something, some product that you don't want, a really good way to do that is to not make it in the first place. So anything that can be done to reduce the amount of, let's say, electricity that is used from coal-fired power plants will automatically reduce the emissions that are created in the first place. So anything that conserves energy, anything that switches energy use to a source that produces less air pollution is then immediately going to reduce the air pollution. That being said, how do we reduce it? And it's nice to say, well, you know, everybody should do this. They're not going to. Remember again that it is industry and agriculture that produces most pollution. So anything that we can do to basically force them to do this, it's either a stick or a carrot. So it is a law that either is going to punish people who violate the precepts of the law, or it is one that is going to give them advantages for, or I guess some sort of plus for following the law. All right, so the big law that we have in place in the United States regarding the Clean Air Act, reducing air pollution is the Clean Air Act. Now, normally you're supposed to know 10 laws, and we will discuss this during the review. This is one, I think this is like the only one that is really specifically referenced in Units 1 through 7. So definitely tuck this one away. When it was enacted isn't that important. Do realize that this is a United States Act. This act is not universal to everywhere on the planet. And then do realize that this monitors 6 specific, these are called criterion pollutants, and they are specific to outdoors. So carbon monoxide, nitrogen dioxide, sulfur dioxide, suspended particulate matter, smaller than PM10, ozone, and lead. So there are secondary criterion that are also monitored, and I want to say there's like almost 200 of them. So they're HAPs, yeah, there's almost 200 of them, but really make sure that you know the big 6. Did this modern monitoring make a difference? Yeah. There are again fines in place for companies and individuals who put out this stuff. The nitrogen dioxide problem has been solved in remember gas vehicles by putting on those catalytic converters that we talked about, and then also lead being put out by individuals via combustion of gas was eliminated by removing lead as an additive from gasoline. Okay, so what is the difference between suspended particulate matter and PM10? What's the difference between PM10 and PM2.5? So we're going to go back and look at page 605 here again. I'm going to leave you with the screen just for 1 second. I'm getting an echo right now, so I'm going to go close some doors so that hopefully it doesn't sound like I'm in a cave. 1 second, so read that. All right, that kind of helps, but not really. So I guess we'll just, oh, that made it worse. All right, keep reading. Let me go fix it. All right, clearly I need a recording studio, but anyway, basically it's just a matter of size. Those numbers will be things that we write down, but you need to get a grasp in your mind as to why we care. And it's because of the diameter. You've got particulate matter. If it's above a 10, usually PM25 and above. That is in micrometers, by the way. It means that your body's system, the little cilia and whatnot that are in your lungs, I'm trying to flip and find this page with the picture of your lungs on it. These little boys right here in the mucus can filter that stuff out. Once you start getting to PM10, these guys can't handle it anymore, and it will enter into your alveolar sacs, the alveoli, and clog those bad boys up. And then when you have a particulate matter of really, really fine, then this is where it can cause problems. And again, when you say it caused problems, you need to be able to say, for example, what it will do is it will irritate your those little alveoli, the little sacs that's where the oxygen exchange takes place. That's what those are for. If those are irritated, it means that they can take up less oxygen. It also opens you up to other infections that can then fill those completely with fluid, making them incapable of bringing oxygen into your system. So please make sure that when you're answering these questions, if you're asked about why particulate matter is a problem for your lungs, don't just say, well, it's because it's bad. You need to follow that rabbit right down to the bottom of its hole. Okay, so I already talked about what a HAP is. It's right here. So you've got hazardous air pollutants, and there's almost 200 of them. Again, do not get caught up in this number here, 188. That is not going to be something that you're asked on the national exam. You really are going to be asked about broad concepts, and you're not going to have a gotcha moment about that particular number. If you don't remember, don't guess. It's better to say the word lots than name a number that somebody would have to not give you a point for. Why is it easier for the U.S. to control air pollution emissions than for countries like Mexico and China? And the answer is just straight up, we have laws. And those laws have consequences, and those consequences can be backed up. There are other countries that do have laws, and they just don't have the manpower or the strength of government to go ahead and back those up. And especially in a place like China, where their particular governing system may or may not put a premium on the health of its citizens in the face of, because you guys have to realize that taking the steps to cut down on air pollution costs money, and so it cuts into your profits. And so if profits are prized over human life, you may or may not get sick because of extra air pollution, but you will lose money if you have to keep the air pollution out of the air. So it's just a philosophy on it's an outlook on what you consider to be more important. What do you think consequences are for companies that violate the Clean Air Act? It's fines. I'm not entirely certain that you can shut folks down, but you get fines every day, I believe, that you violate those particular laws. Explain how emissions trading or cap and trade program works. Okay, so here's how you look at it. Let's say that you are trying to slowly step your country towards reducing air pollution. So you go ahead and set a cap for your country. So you're like, okay, guys, it is now the law. We're only going to make 30 pounds of air pollution. Okay, that's a ridiculous number, but just let's go with it. All right, so 30 total. So that means if you have 30 corporations, I'm going to give each one of you a ticket for 1 pound of air pollution. Everybody gets the same amount. There you go. Or maybe even you do it like, okay, your factory has this much square footage, so you get this many tickets per square, whatever. You figure out a system and you go ahead and dole those out. If you go above the amount that you have based on your ticket, you get fined. So what ends up happening is this right here. A utility that emits less than its allotted amount has a surplus of pollution credits. So here are some things they can do with that. They can expand and create more air pollution because they have the credits for it, or they will sell their credit to another company that is producing more pollution than they are given credits for. The reason this makes me laugh is that companies can make money and sell something they don't do. So I'm selling you this credit for pollution I didn't create. It's really fascinating. So the pros are that if you, as a company, work on not putting out a lot of air pollution, it means that you can essentially make a profit on reducing your air pollution. The cons are it doesn't incentivize everyone to go ahead and reduce their air pollution. So to me, it's kind of a first step towards everybody reducing the amount of pollution that they produce when you go ahead and cap it for your country as opposed to capping it for your individual industry. So do make sure, I've kind of really summed this up, do make sure that you read these couple of paragraphs here and really understand how that works. All right, so how do we reduce pollution if we are not stopping our production of creating electricity via stuff like coal-fired power plants? Okay, so there's nothing we can do about, well, let me back up. This is an air pollution section, so we're not talking about the solid waste that is produced when you burn stuff. We're just strictly talking about the air pollution. So we're not making that pollution disappear. We are taking it and basically putting it somewhere else. Please realize that pollution, toxins, it doesn't go away. We just put it somewhere else to deal with it at another time. All right, so the thing that produces the pollution, where it's emitted, is going to be smokestacks. So think about these like cigarettes. Back in the day when people used to smoke, they smoked without any filter whatsoever. That meant that 100% of what was burning in that cigarette ended up in people's lungs. Now again, we have filters on cigarettes, but that doesn't make smoking any more good for you, because there's plenty that can make it through that filter. But it's an apt description. The filters that we have on smokestacks work a lot better than those that you find on cigarettes. All right, so there's two kinds here: the electrostatic precipitator and the wet scrubber that that you're responsible for here. There are a couple other kinds that we'll talk about in the supplemental videos. Okay, so let's go ahead and talk about what these are and how they work. I'm going to give a very basic description of these. Doesn't look like your book goes into too much detail, but I mean, the pictures are pretty good. So let's talk about the electrostatic precipitator first. Think about what that word electrostatic means. It means electricity, and then you know what static is. That's what makes socks stick to your shirt. It's just because your socks are negatively charged and they stick to your positively charged shirt. So again, I'm doing a lot of talking. What does this all mean? It means that the physical chunky stuff, so all of that particulate matter, if you can put a charge on it and then you pass it by a plate that has the opposite charge, it just sucks all of it out. Now, why don't we just put a filter on there? Remember, these particles are so small that not even your lungs can filter them out. So you got to do something else, and nothing can escape charges. So again, this is specifically for particulate matter. This doesn't work with anything like NOx or SO2, or if let's say lead and mercury is an ion, as an example, it may not work with that either. So this only is going to work with particles that are charged. Definitely that particulate matter. I'm not sure about the heavy metals. Now, what do you do to get the other chemicals out? Well, you can use things like a wet scrubber. So again, this is exactly what it sounds like. You largely spray this with water to get particulate matter out, but then also if you have chemicals in that water that react with the stuff in the air, then that means you can also pull some of that out. I mean, think about SO2. It will react with water to form sulfuric acid, which is liquid, and so that chemical reaction will pull that out. Same thing with NOx. But there are other chemical processes that you can launch within that water to go ahead and take that air pollution and translate it into an ion that only exists in water, or a liquid something that you can then pull out of this. Now, how does this get pulled out? This is straight up gravity. That's it. Now remember, again, just because we have removed this from the air doesn't mean poof, it's gone away. It is now solid waste, and it still has to go somewhere. So there is no way. So the pros are, you're not breathing it anymore. The cons are, it's got to go somewhere else. And if it is not in a secure landfill, this can then end up ultimately in our water supply. So again, these are two different methods. This one uses charges to get rid of stuff. This one uses water and chemicals within the water to go ahead and clean the air before it's released. And remember, there are still things that are not great for our environment that are being emitted, specifically things like carbon dioxide. And when I briefly touch on climate change, sorry about that, before the national exam, we will talk about it then. List several ways that can be used to reduce motor vehicle emissions. We already talked about a catalytic converter. We talked about removing lead from gasoline. Oh, okay. So right there, we've got another description of what's going on here. And then how do we remove stuff from emissions from motor vehicles? 19.22. So, guys, again, the best way to reduce air pollution is to prevent it entirely. Don't use so much fuel. That is not difficult. And this is another thing. Making sure your car is in good running order is another way of reducing oil drips, which go into groundwater supplies. Making sure that your catalytic converter is working at 100%. Yeah, and then again, making sure that everybody does use those catalytic converters. There are states where I think every year you have to get a sticker for your car because it has to be examined by a mechanic to make sure that it is not emitting certain types of air pollution. And then what about indoor air pollution? Again, active ventilation. That is, it's not just opening windows. You have to open 2 windows. In the case of radon, you have to have an active pumping system because that gas is so heavy. This one right here, plenty of houseplants, I would kind of avoid this. There are some conflicting information as to whether or not houseplants do a whole lot for indoor air pollution. Yes, they do provide oxygen, and there is a lot of good research that shows us that when you look at nature or have natural things around the house, it does help with your physical and your mental health. Whether or not these things actually pull pollution out of the air, it's up for debate. Okay, so now let's go ahead and talk about acid rain. So we're going to flip to 609 through 612. Please try to not pass out with this stuff because there is chemistry. So let's go ahead and talk about it. So, first of all, remember that acid rain is not a primary pollutant, it is a secondary pollutant. And it forms when either SO2 or NOx is emitted, and it reacts with the water in the air to either form sulfuric acid or nitric acid. Sulfuric acid is largely associated with industrial smog, as an example. Sulfur is a very common component in coal. And then nitric acid, coming from NOx, which remember is NO and NO2, is largely associated with photochemical smog because NOx is produced by car exhaust where it's not controlled by a catalytic converter. So definitely no formulas, no ions. I will make sure, again, that this is a part of our little cheat sheets that we put up on our wall before the national exam. These two ions can then form solid salts, which is why this is better called acid deposition than acid rain, because sometimes these bond with a positive ion, a metal with a charge, and then falls to the ground as a solid. Okay, so again, you have wet deposition and dry deposition. So there's all of this stuff here, and it's kind of key that this is a regional air pollution problem. It would probably help if I looked at my questions that I asked you. Okay, I talked about all of that. Blah, 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 blah. Okay, regions affected by acid rain. A lot of the times, smokestacks are really high, so that they poke up into the upper troposphere. Remember, air pollution, by the way, happens in the troposphere. It happens where weather is, which means that it is greatly affected by weather patterns. If you are in a city with a lot of air pollution but a lot of constant wind and you're not sitting in a valley, you may never experience the effects of air pollution. The folks who live downwind of you, who get all of the wonderful air pollution that you've created that they're getting, may be suffering from something they didn't create. This is one of the reasons why when we talk about things like air pollution, it's really tough to talk about local or even country laws and how we deal with it, because air don't care. It goes everywhere, and it doesn't just like, well, sorry, I'll just deposit this pollution right here where it's created. Again, there is no way. We are a closed system on this planet, and pollution that is created in one place can affect the people who live somewhere else. All right, so regions affected by acid rain. A lot of times the people who suffer from acid rain are the people in rural areas. Why should the people in cities care? And the answer is, hold on a second. The answer is, this is where we grow our food. And one of the things that acid rain does is it reduces the productivity and can entirely kill plants. Not for the reason that you may be thinking right now, but and then that means that these folks have less to eat. What kind of soil can reduce the effects of acid rain? For those of you who did not take chemistry, there are two things we're going to talk about right now: acids and bases. With acids, they all start with an H. It's a hydrogen ion. That's the thing that makes an acid an acid. What it does to your skin cells is it basically makes everything unravel, which is why people who end up getting acid on their skin, it basically eats away the skin. It just makes everything come undone. So there is another kind of chemical called a base that usually has something called a hydroxide ion on it, an OH minus. If you don't know what this is, please go look it up. When an H plus and an OH minus get together, it forms water, which does nothing in terms of being, quote unquote, bad for you. So when an acid and a base get together, they do something called neutralize each other. By themselves, acids and bases are very not good for cells. When you get them together, they form water and then just salt. So if you have a soil that has a buffer in it, which is a basic compound, it can deal with acid deposition okay. One of the biggest buffers that's a base, which we have talked about before, is limestone, calcium carbonate, CaCO3. This is also one of the reasons why acid deposition is so harmful to a lot of statues, because marble is based in calcium carbonate and readily reacts with acid, meaning that it dissolves and goes away. I just went off on a tangent, sorry about that. So if you have soils that do not have that in there, it means that acid is able to do its thing when it's in the soil. and we're going to talk about what that thing is. Okay, so acid deposition, human-made structures, especially if those structures are made of something like limestone, dissolves them completely. We have statues that have stood for thousands of years that ever since the Industrial Revolution have lost their faces, lost their detail. A lot of the statuary in Greece, as an example, made in BC times, was brought inside because the damage that had been occurring to it since the beginning of the Industrial Revolution. Let's see, what effect does acid deposition have on human health? I'm sure you can imagine that, yeah, and again, please make sure, even though I don't address a paragraph precisely, that you are reading. This is really key right here. Most air pollution is created in Asia, especially China. It's something I'm going to talk about in one of the PowerPoints. There is a brown cloud of photochemical smog that basically sits over China and parts of India, and it gets into the jet stream and ends up in California. All right, so anyway, human health. You can imagine that breathing in droplets of acid is probably not going to be great for your lungs. Besides damaging the lungs, and lung tissue doesn't always grow back, meaning you can have permanent scarring and permanent a reduction in your lung function. Not all at once, but over time. So it's a chronic problem. You can also will aggravate asthma, aggravate emphysema, all of the same other stuff. It's a lung irritant. What you really do need to understand are the steps that are involved with the impact on aquatic ecosystems. Okay, first of all, when acid hits a water, please remember it reduces the pH, not increases, it reduces it. Why is this a problem? Well, for us it may not be, because we can tolerate a goodish range of pHs in our water. If you like lemon water, lemon's a pretty acidic thing, that's why it tastes so tart. Where was I going with this? Oh, but when you have something like fish and other aquatic organisms, remember they have a very narrow range of tolerance. So if the pH changes beyond what they can tolerate, they die. But there is a longer chain of events that affects aquatic fish, and it is so if the acid rain doesn't fall directly into the water, let's say you have runoff. So when acid hits the soil, why is that a problem? Because as it travels, it dissolves metals like zinc, like aluminum. If you're going to remember one, remember aluminum. And aluminum ions, when they get into fish gills, it irritates their gills, and it causes excessive mucus formation, which clogs the gills and kills them. So a lot of times when fish die, it's not because the acid rain that fell onto the water, it's because it fell over here on the land, gathered up metal ions like aluminum, got into their gills, and basically these fish drowned in their own spit. So you should be able to articulate the sequence of events by which acid deposition kills these things. This is not acid falling on something and eating it away, okay? It's more complicated than that, which is pretty much how this class is. It's always more complicated than that. And then also, okay, we've already talked about all of that. We're going to talk about how acid deposition reduces plant productivity here in a second. And again, it's not that acid lands on the leaves and eats them away. It affects plants in two ways. One is that, again, it's called mobilizes these ions. So what does it mean? It means that if there are any calcium deposits or magnesium deposits in the soil, turns them into ions, and then that means that water can leach it away, or it can go into that subsoil, that B layer that we've talked about before. Remember O, A, E, B, C, it goes through that zone of leaching into the subsoil where roots can't get at it. So again, what it does is acid will make these things into ions, and then because they're ions, all it takes is more water to force it into a part of the soil that roots can't get into anymore. But then also what it will do is it will ionize things like aluminum, lead, cadmium, and mercury, which makes those easier for roots to uptake. And now the plant itself bioaccumulates this stuff. No, there are no fatty tissues in plants, but they just get stored in the plant cells because that's what plants do. And then the plant dies. So again, acid rain doesn't hit the plant dies. It is because the acid either robs the soil of nutrients, and be able to articulate how that happens, or it mobilizes ions that are easily uptaked by the roots that then kill the plant. This should distress you in terms of uptaking of things like lead and mercury, because imagine if crops are doing this. What that means is that the crops are concentrating this within their cells. So you could even end up with crops that have high concentrations of the stuff in it, and then you eat it. But again, you can imagine if a plant is dying, it's reduced its productivity. Okay, so let's see what else we need to answer. Forest health, we already talked about that. So, and apparently also, here's something else of how this can reduce plant productivity. Plants also have a range of tolerance, so if the soil is too acidic, they just don't grow as well. How can the incidence of acid deposition be reduced? Number one, stop creating the primary pollutants that lead to the secondary pollutant of acid rain. That's super easy. But if you do have acid deposition actually happening, then you need to go ahead and add a base to the soil. So add some limestone to your soil. That's basically just called lime. And let's see if this says anything else about that. Nope. Okay, so, and again, this is what a forest looks like that's undergone acid deposition. This is a great graphic. One of the things that we will do with your book is that we will make little notes, so that way whatever the topic is in the national exam, if you need to reference something quickly, you will be able to do that. So please make sure that you're familiar with graphics. And that brings us to the end of this video. We will go over noise pollution in the supplemental PowerPoints.